AP Calculus AB, finding the derivative of logarithmic, exponential, and other transcendental functions. How you like that, Mr. Conroy? Better? I know, I'm just saying. Okay, we're going to try to get through just these two problems and see if we can get this done. Remember, we're going to try to use the properties of exponents, the properties of logarithms to make this easier for ourselves. So, isn't it true that we can rewrite this as this, that y is equal to 1/2 ln of x plus 1 over x minus 1? Why is that true? Right, because this right here can be rewritten this way, can't it? And we know from our properties of logarithms that we can take our exponential value and roll it back as a coefficient, so that's what we did here. Everybody go with that? So from here, I'm just going to break this out a little bit more using, using rules of exponents. And say that this is the same as y is equal to 1/2 times ln of x plus 4, what? Minus, Joel, ln of x minus 1. Isn't that true? No, we're not taking a derivative yet. No, not taking a derivative yet. Just using, I'm trying to put this in some form that I can recognize a little bit better. There's going to be lots of problems like this on the multiple choice section. We got to kill this section, right? So when we see this stuff, we have to be okay with it. So what are we going to do now? Now, right? ddx, right? So y prime. Somebody describe what 1/2 is. It's just a constant multiple. Times, whoops, I'm going to do this. And what's the derivative here? 1 over x plus 1 times what? 1. Times 1, right? Because we're supposed to take the derivative of the inside, but the derivative of x plus 1 happens to also be 1. But I did do that, Joel, so if you want to do that. Minus 1 over and remember here I also did the times 1 here, right? Everybody good with this? Now I'll see if I can make you want to hurt yourselves. Got to clean it up algebraically. So to clean this up, this is where the algebra comes in, because I promise you on the exam, if you're thinking about your algebra, you're going to get a lot of really good answers. If you're not, you're going to be really pissed off, because you're going to be asking yourself, why isn't the answer there that I'm anticipating? This answer right here, this is great calculus. This is good calculus, but they want to see the algebra. So I'm going to multiply this. This times this is x squared minus 1, isn't it? I'm going to multiply this side by x minus 1, which gives me x minus 1, doesn't it? Here I'm going to get this negative sign is this one, but I'm going to multiply this by x plus 1. So I get here x plus 1, right? And I still have this 1/2 hanging around out there, don't I? When I multiply this negative sign in, this becomes negative x, doesn't it? This becomes negative x, and this becomes negative 1. Isn't that right? So we get 1/2, right? Negative 2 over x squared minus 1, right? Is that still good? That's still good math, isn't it? This 1/2 cancels this 2 up here, doesn't it? This 2 goes to 1. This goes to 1 there, doesn't it? Now look at this for a second, because this is a really good looking answer, but it's not the answer they're going to give you. Instead, they're going to give you this answer, and I need to know where they got it. They're going to offer you up, and it's the right answer, that y prime is actually 1 over 1 minus x squared. What are they going to do here? Yeah, they're going to take this negative sign right up here. They're going to move it to here. That's totally fine. And they're going to multiply this negative sign through the bottom, because they might not want to leave a negative sign at the top. I'm just telling you what to look for. It's just the algebra of it, isn't it? And that was both of them? That was just one? God, man. So here we go. I'm going to use properties of logarithmic functions again, Joel. I'm just going to rewrite this as f of x is equal to x. I'm going to take this as 1/2 ln of 4 plus x squared, right? Minus ln of x. Everybody see what I did here? Bill, this 1/2 is because to the right, the square root means to the 1/2 power. We know rules of logarithms. I can pull this exponential value back to the front as a coefficient value. Right, and it was only of the top. It wasn't of the bottom also. So I'm going to start, now I'm going to start to differentiate, Ken, and I think I'm going to do this. Here's my 1/2 is my constant multiple, right? It's 1/4 plus x squared, isn't it? Times good job, Ken. Times 2x minus 1/x. This one's a pain in the neck also, isn't it? Well, this one's not terrible. 2x times 1/2 is just x, isn't it? So I'm going to take this as x over 4 plus x squared minus 1/x. Is f prime at x. Cleaning up the algebra now. I'm going to multiply this side over here, Danny, by 4 plus x squared over 4 plus x squared. This side over here, I'm going to multiply this by x over x, right? So here we get x squared minus 4 minus x squared all over x times 4 plus x squared is equal to f prime at x. Now what, Joel? The x squareds cancel. And I'm saying to you, Joel, that this is possible. It's possible they just leave that negative sign sitting out there. Like that. It's possible they would distribute it. Usually not, but they could. You just have to kind of be prepared for it. What I would do is here, when you get to this part right here, make sure this is really important. Make sure you're looking at your multiple choice possibilities, the answers, and then start cleaning up your math accordingly. So if they provide you some really clean answers, then you know you got to clean up some more. All right?